Everyone, welcome back to Calculus 3. It's all about double integrals for now. And a double integral over a general region, or we said there are so-called type 1s and type 2s. Okay, and accordingly, the double integral should be evaluated in different ways. How about let's work on one example on the text again. It's example 5.12. Evaluate double integral. Okay. And actually the textbook did indicate this as type 1. But anyway, before I start, this is the region we are talking about. Maybe you want to ask yourself, or maybe that's my question to you, do you think this can be considered type 2? And indeed, I want to tell you for a triangle region like this or some other triangles, usually it can be considered as type 1 and type 2 both. And also the textbook did emphasize consider this a type 1. Do you know why? Well, I think to answer this part of the question, if you watched my other video, we did say the order doesn't matter. And in this case, the order does matter, okay? And certainly, if you have more questions, send them email, and we talk about this example during those drop-in sessions. For now, we're just going to follow the arrangement as on the textbook. Consider this as type 1. So I'm looking at this triangle here as type 1. It will have to be bounded by two vertical lines, which means x running from 0 to 2. And then a single curve in a lower place, that's y equals 1/2 of x. A single curve on the top, that's 1. Okay, this is in general the description of type 1 region. And then for this type 1 region, the integral will have to be evaluated in terms of y first. So that is accordingly the arrangement of the iterated integral, okay, in terms of type 1. We do y first, then x. And then evaluate this integral in terms of y first. I hope you can understand this part of writing. X squared is a constant, that is stays. So this is derivative e to the xy. X is constant. Okay, so the antiderivative I'm having here is 1 over x times e to the xy. And just to remind myself to this moment, I will have to replace y as 1, which is the upper bound, and y as x over 2, which is the lower bound. So I did all the calculation. I think I just took the things from the textbook. Most I should be fine. Yeah, I think so. So when y it is replaced with 1, okay, x squared times 1 over x, that's a single x, right? E to the xy, y is the one that's e to the x. Okay, that's all I have. And then when y is replaced with x over 2, x squared times 1 over x, that's a single x. And this part, it tends to be x squared over 2, right? So in the integral, it is evaluated using the fundamental theorem of calculus. We got those two terms. As expected, after evaluating this in the integral, evaluating the integral in terms of y first, we do have an expression with x. So this round, we do the integration involving with x, with respect to x only. And indeed, you all really need to know the integration techniques very well. For this time, the product part, I did use integration by substitution, integration by parts. This product part, it is from integration by parts. And this part here, it is integration by substitution. I believe, yeah, it is the integration by substitution. I'm taking u as x squared over 2. So x dx together, that's du. So this is e to the x squared over 2. This is the evaluation with respect to x. Replace x with the upper bound 2 and replace x with the lower bound 0. And I'm going to say you help me double check with the numbers, and hopefully it should be alright. I'm not seeing clearly how I get to that 2 for the moment. So I'm putting some dots there. That means you want to fill in some work, or if you are reading the textbook, if you are watching the video, make sure you do figure out how we get the number correctly. Okay. Evaluate a double integral as a type 1 region over type 1 region. So next one, it is evaluate double integral over type 2 region. The double integral we are having here, it is in this fashion. Actually, this part, I just want you to know everything is given. But you really want to be very careful if you do understand the situation. So what I did, somewhat I tried to sketch the region. Certainly I took the graphs from the text. Okay. And what I see here, if you look at the region, you may want to know this is really, I think, in an easy way. Okay, it is more conveniently, it fits in the situation of type 2 region. It is bounded by 2 horizontal lines and a single curve to the left, a single curve to the right. And also, if you look at the arrangement, the description of this region, it does fit for type 2. And also, after seeing the graph, if you like type 1, I say it is possible. It is possible. But anyway, you really need to have an extra line at this point 1 here. And then to the left, that is a type 1. To the right, another type 1. There are 2 type 1 regions. So you better just consider this a single type 2. Single type 2. Okay. So I'm recognizing this as a type 2 region. Remember, in terms of type 2 region, we evaluate in terms of x first. That's what I did. Make sure you match the bounds for x correctly. So indeed, this is the inner integral. Still take a look if it really makes sense. After evaluating the inner integral, I suppose we still have a bunch of y's left, right? X should be gone. So it makes sense, we need to calculate the integral in terms of y. Okay. And before I move further, maybe let's take a look if I'm getting this part of calculation correctly. Integration in terms of x cubed, x times y squared, y is constant. Replace x with the upper bound and the lower bound. Then do a subtraction. It's quite long. I guess I'm not going to read this entire thing through. Okay, you may want to pause the video if you are watching and do some writing to see if everything makes sense to you. Okay, basically for this part, I guess still easier to follow. Replace x with the upper bound, 2 occurrences of x, and replace x with the lower bound. And then I think the tricky part, it's not a necessary tricky part, somewhat I would say, the calculation part, you want to do it very carefully. Multiply to the power third, and then multiply this thing out. And then I follow the arrangement on the textbook. It's a polynomial in terms of y, in the ascending order, right? 0, 1, 2, 3. And then calculate antiderivative for each. Keep in mind at this moment, everything it is in terms of y, So if you see the idea, hopefully it's not that to follow. And then I skipped some calculation, and also I'm going to skip some discussion here. You plug in 3 for y as for the upper bound, -2 for y as for the lower bound, and then do all the calculation. Seriously, I did not check. I just took the number from the book. But anyway, for you guys, I'm going to say you take a look if everything makes sense to you. Hey, thank you for watching. I'll see you next time.